Hola, me llamo Neil.
Hola, me llamo José Parada.
Vamos a presentar nuestra evaluación de la ingeniería. Usamos 4 resistores de 220, un montón de cables, un indicador de 7 segmentos, 2 tablos de circuitos, un para el contador y el otro para el contador de cumpleaños.
También usamos 5 chips de circuitos integrado marca 74 LS00, 6 chips de circuitos integrados marca 74 LS02. Ok, vamos a dejar de hablar español. First, we started with our engineering notebook. We made a truth table which told us what we needed to build. After we've gone through making the truth table, we discovered that for inputs A and D, one circuit could be made for both of them. B and C would also use one circuit, E and F would use another, and G had its own separate circuit. So in reality, we'll need to build 4 circuits. Knowing this, we went into writing logic expressions for each circuit. Our first was for A and D. For A and D, we had to find a simplified logic expression using Boolean algebra, and we did. After we found the simplified logic expression, we sketched out a circuit using NAND implementation. For circuit B and C, we found a simplified logic expression using K-mapping this time. Again, we sketched out a circuit using NAND implementation. For circuit E and F, we also use K-mapping to find a simplified circuit, simplified logic expression. But this time around, when sketching our circuit, we're using NOR implementation. For circuit G, again we use K-mapping, and we sketch out the circuit using NOR implementation as well.
So what we see here is our counter. This counter counts from 0 to 7 in binary, and what it'll be used for later on is to help keep track of the circuit and how it will display numbers. As you can see here, this is our A and D circuit, and it is using NAND implementation. This is the B and C circuit, also uses NAND implementation. This is the EF circuit, however it uses NOR implementation. Lastly, this is the G circuit, and it also uses NOR implementation. And here we have our final product. We connected all 4 circuits that we built previously to our counter, and it should be able to display the date, the birth date, October 30th, 2000.
So after we built all the circuits on Multisim, I went ahead and drew a diagram of each separate circuit. So as you can see here, we have circuit AD that uses 2 ICs. And yeah, it might look kind of messy, but here's what I used to basically map out where I would want to run the wires. And I did this before every single separate circuit. For AD, of course, you have BC down here, E and F down here, and G up here. And we did this for each circuit just to make sure that we knew what we were going to do and we knew which wires were going to go where. And although it was messy, like I said, it worked perfectly. When we all put it together, it worked perfectly the first time.
After the diagram was drawn, we then went to build the circuit based off of the diagram itself. Building the circuit here, we then connected it to our counter.
And as you can see here, here's a working circuit displaying the date of birth 10/30/00.
Excuse me, sirs. What is the relationship between the resistor values, the amount of current flowing, and the brightness of a 7-segment display?
Well, if you don't know already, the power that an electric current has through a circuit is called the current, and it's measured in amps. So basically, in our circuit, the amperage going through would be very high. So when it would illuminate the seventh segment, it would be very, very bright, to a point that it might even break the seventh segment. So to counteract that, we use resistors, and they do exactly what the name sounds like it does. It resists. So basically, the current going through it dampens. It dampens in here. It comes out in a dampened current.
Lesser amounts.
So when it goes here, it's not as bright, but it usually keeps its lifespan longer.
Why is it more difficult to design logic circuits with NAND logic or NOR logic than it is straightforward AOI logic in terms of circuit implementation?
Well, let's say in terms of inversing, in this case, when I want to inverse something, I would just use a regular inversing chip to inverse the whole input. But in NOR or NAND, if I want to inverse something, I would have to use multiple NOR and NAND in a series to end up doing the inversion, making it more complicated through the experiment. That wasn't the word.
2. Why does a logic expression require fewer ICs to implement if NAND logic or NOR logic is used than would be required if AOI logic was used?
Well, first off, an IC is one of these little black chips. And in each one of these black chips, they have a specific type of gate. For example, this 74LS00 has only NAND gates in it, and there's about 4 of them in here. So because these only have NAND gates in them, circuit using only NAND implementation will only need one type of IC, these. But if you were to use an AOI implemented circuit, you would
have to use multiple type of chips because each chip has a different type of gate.
And overall, if you're going to build an AOI, it's going to be larger and probably more expensive to manufacture.